All right, if you missed our electron configuration lecture, then we're going to fill in the first couple pages right now. So, I'm just going to go through these. We'll pause for questions. In a neutral atom, the number of electrons is equal to the number of protons. And in the Bohr model, electrons orbit the nucleus in energy levels. So right here, as an example, I have a model of lithium. I have 3 protons here. I have 3 tiny electrons. These are going to be the same because my atom is neutral. I can count 4 neutrons, and then the atomic mass is the protons plus the neutrons, so that's 3 plus 4 is 7. Now I have 2 electron shells, and this is a trick question because you only ever have 1 nucleus. So, we know now that Bohr was wrong if you did the electron dart lab, but he was sort of right. So we have energy levels, but we also have something called orbitals, and that means that my electrons can go in a shape like this at any given point. So what does that look like? If you're at a stadium here, the energy levels are the rows, those are set, but your orbitals are your sections. And then if you're in school, these are your grade levels. You go from 9th to 10th to 11th to 12th. And then what you can go in between on those grade levels are your classes. Orbitals are like where the electron goes when it's in the wave pattern. So they're going to be your s, p, d, and f orbitals. And they can hold 2, 6, 10, and 14. So it's plus 4 each time. Go ahead and pause that video and make sure that your page looks like this. Moving on. The arrangement in the atoms, what this whole model is about, is called electron configuration. And electrons surround atoms in orbitals. And the electron configuration tells us where these electrons actually are. So to write it, the first step is find the total number of electrons, and you do that by finding the atomic number on the periodic table. Then you need to figure out how many energy levels they have, and also you look at the periodic table. It's super easy, you just look at the row. So if the element is on the second row, it has 2 energy levels. So I'm going to give you this information right here, just really quickly. So that's 8, 9, 12, 15, 18. That'll be 2, 2, 3, 3, and 3. These are on the second row, and these are all on the third. Now, these are your orbital boxes and what they actually fill together. So 1s always has 2. Unless you are hydrogen, the 1s box will have 2 orbitals in it. So everything from helium on will always have 2 down here. Now, for this, I need to place 8 electrons. So I'm going to put 2 in the 2s box. Now that's full. So I've placed 2 and 2 and 4, so I have 4 left. So I'm going to put 4 in here because it can hold 6. This one is going to be 2, and again, all of these are going to be 2 because they're more than 4. So 1s and 2s, you can usually assume that they have 2 in them. I'm going to put 5 here, 6 here, that's 10, so I have 2 left. 6 here, that's 10, that's 12, and now I have 3 left. And then this one's totally full. So that was sort of rapid fire, and I'm going to break it down to be a lot smaller on the next page. Lithium has 3 electrons, so we have 3 electrons to place, and we diagram these by arrows, but they're special arrows. They're in halves. Okay? So, lithium has 3 electrons, and each electron looks like this. So I have 3 electrons to place. Now there are a couple rules to follow. The first is the Pauli exclusion principle. And that states that electrons in the same orbital have opposite spin. Okay? And what that looks like is in a box, that's an orbital. You're going to go up and down. And then the next rule is the Aufbau principle. And that says you fill the bottom levels before moving up. So I have 3 electrons to place. So I always start at 1s. So I have 1 here, 2 here. Now I've placed that one and placed that one. Now I need 1 more to place, so I put it in the 2s box. You won't get to this till the next page, but I'm going to write its electron configuration without the diagram. How many do I have in the 1s box? I have 2, so that's 1s exponent 2. How many do I have in the 2s box? I have 1, so that's 2s exponent 1. You do have to write the 1s here. Now, 2 plus 1 is equal to 3, and the atomic number is equal to 3. So if those match up, then I know I did this correctly. So nitrogen has 7 electrons, and this is the other rule. So Hund's rule states that in the same level, do not pair electrons unless necessary. So what that means is, let's say that I have 1 row left on the bus. Everyone has taken seats except for this row. And right here, there's a man sitting on the bus, and he really smells. Are you going to go to this seat, or are you going to take that one? You're probably going to take this one. So I call this the rule that says don't sit next to the smelly man on the bus. So we have 7 electrons to place. So Aufbau's principle says that we fill the bottom levels first. So I'm going to put 2 here. So now I have 5 more to place. Now I need to fill up the bottom still, so that's 2s. I'm going to put 2 more here. Now I have 3 left to place, and I'm going to go to my 2p orbital. But I don't want my electrons paired unless they have to be, so I'm going to go 1, 1, 1. They have their space, they're not with anyone smelly. And then to write that electron configuration, I'm going to write 1s2, 2s2, 2p3. So we're going to do neon and sodium. Neon has 10 electrons, so I'm going to fill up 1s, fill up 2s. I have 6 left. Get in the habit of spacing them out on the p orbitals. So 1, 2, 3, then backfill 4, 5, 6. So we did have to fill this up before we went to 3s, but we filled them up one at a time. Then the electron configuration for that, 1s2, 2s2, 2p6. And our last one, sodium. 1, 2, 3, 4. These are filled, so now we can move on. 1, 2, 3, 4, 5, 6. That's 2, 4, 6, 8, 10 electrons. We have 1 more, so it goes there. So my electron configuration is 1s2, 2s2, 2p6, 3s1. And you'll find the pathway to fill out on the next page. So on your own, if you're watching this and making up these, I want you to go ahead and start these answers, 15, 20, 22. Try them. When you're done filling up the diagram, call me over, and that's how I'll know you're ready to move on.